This video is about how to evaluate a function in function notation and identify dependent and independent variables. So a function is a relationship between two quantities in which one quantity is associated with a unique value of another quantity. So let's look at the example of two vending machines. So in the first one we have the refreshments vending machine, which is a beverage containers only are not intermingled, which means they're not mixed together. So let's look at what happens when a customer goes to get a drink at the refreshment machine. So notice if they hit A, they're going to get orange juice. If they hit B, they're going to get apple juice. If they hit C, they're going to get skim milk. If they hit D, they're also going to get skim milk. If they hit E, they're going to get chocolate milk. And if they hit F, they're going to get water. So notice that that means that every code, every button that they're hitting on the vending machine is going to give them a unique beverage. One machine, two buttons share one drink, but each button only has one drink. So if I know I touch that button, I'm going to get the drink that I requested. Now, if we look at the cold drinks vending machine, some of the beverages are intermingled. So if I hit A, I'm going to get orange juice. If I hit B, I'm going to get apple juice or skim milk because it switches halfway through. If I hit C, I'm going to get skim milk. D is going to deliver chocolate milk. E is water. And F is also water. So notice when I hit the cold drink machine, if I hit button B, I'm not really sure what I'm going to get because there's two outputs. There was the apple juice and there was the skim milk. So based off of those machines, we want to know which vending machine represents a function and why. So in this case, we would want to say that the refreshments is a function or represents a function because each input is assigned to a unique output. So another way to say that is that every button that I'm going to hit, I'm going to get one type of drink out of the machine. So then which one does not represent a function? We would say that that would be the cold drinks does not represent a function because input B, which is that button, has two different outcomes or output. So it doesn't have a unique output for every button. So another way to describe what you see as the type of beverage you will see is the function of the code. So f of A, remember if we hit button A, if we look back at our image, A gave us orange juice. So if we would say is a function of, so when we hit that button, we would get orange juice. When we hit button B, we get apple juice. When we hit button C and D, we're both going to get skim milk. When we hit button E, we get chocolate milk. And when we hit button F, we get water. So let's use function notation now to evaluate some functions. So when we're looking at function notation, the letter out front is going to tell us which equation we use. So number 3, we have f of 10, so we would use our f equation. We are going to then take the value that is inside the parentheses, so in this case 10, and substitute it in for x. So when I rewrite this equation, we would have 3 times 10 squared plus 5. And then this just becomes an order of operations problem. So the first thing we want to do is square 10. So 10 squared is 100. 3 times 100 plus 5. 3 times 100 is 300 plus 5. Gets us 305. So all we're doing is we're taking the value that it's giving us and substituting for x in the equation. So in number 4, we have g, so we're going to use our g equation of negative 22. So we're going to put negative 22 in for x. So negative 22 minus 11 would get us negative 33. In the last equation, we have h, and we have 0. So we're going to put 0 in for x in the h equation, and we would get negative 5 times 0 minus 3, which would be 0 minus 3. So our answer would be negative 3. Now, in 6 and 7, we have coefficients out front. So what's going to happen is we're still going to use our f equation, and we're going to put negative 5 in for x, but then we're going to multiply that by 3 once we get a solution. So I'm going to write 3, and then in parentheses, I'm going to put what I substitute into my f of x equation. So I would have 3 times negative 5 squared plus 5. So everything in parentheses is just this equation rewritten with my x value. So I'm going to do my parentheses first, and I get 3 times, and then parentheses 3 times 25 plus 5, 3 times 75 plus 5, so 3 times 80 would get us 240. In number 7, I have a coefficient of 2 for the h equation, and for the h equation, I'm going to put in negative 4. So I'm going to write negative 2 outside my parentheses, negative 2 parentheses, and I'm going to substitute negative 4 in for x. So negative 5 times negative 4 minus 3. And I'm going to go through and simplify. So first I'm going to do the parentheses, negative 2 times 20 minus 3, negative 2 times 17, which would get us negative 34. Now, when I start to look down at number 9, 10, 11, and 12, I have an operation. So now I'm going to do multiple equations at the same time. So in 9, we have v of 5, so I'm going to put 5 into the v equation plus w of 2. So I'm going to put 2 into my w equation. So I'm going to do each equation separate. So I have negative 3 times 5 plus 11 is my blue equation for representing the v. And in w, I'm going to have 2 squared minus 2 times 2. So I'm going to simplify each of these separately first before I add them all together. So I'm going to do the blue equation all the way through, negative 15 plus 11, which is negative 4. And then I'm going to do the red equation separate. So 2 squared is 4 minus 9 times 2. 9 times 2 is 18. So 4 minus 18, which gets us negative 14. And then we're going to carry down that operation that was in the middle, which was our plus. So negative 4 plus negative 14 gets us negative 18. So we're going to do each equation separate, and then at the end, combine them using the operation that's in the middle. So in number 10, I have a v equation for negative 3 of x, and a w equation where I'm using 4 for x. So I'm going to rewrite each equation, negative times negative 3 plus 11 for the blue equation, minus, and for then my pink equation or the w equation, 4 squared minus 9 times 4. I'm going to go through and individually solve each of them. So negative 3 times negative 3 is 9, plus 11 gets us 20. And in the red equation, 4 squared is 16, minus 9 times 4, which is 16 minus 36, which is negative 20. And now I'm going to subtract these. So remember, when you have two subtractions in a row, that becomes an addition. So I really have 20 plus 20, which would get us 40. Now, in 11 and 12, it's the same idea, but now I have coefficients involved. So just like before, I'm going to go through and multiply with my coefficient at the end. So for the v equation, I'm going to use negative 4. And for the w equation, I'm going to use negative 5. So when I rewrite this, I have 3 parenthesis negative 3 times negative 4 plus 11. I'm going to keep my minus sign in the middle. And then I would have negative 5 squared minus 9 times negative 5. Make sure that you are putting that w equation in parentheses as well, because even though there's not a coefficient here, it's really a negative 1, so we need that negative sign to go to our whole answer at the end. So I'm going to go through and simplify this. So I get 3 times 12 plus 11, which is 3 times 23, which is 69. And then in the red equation, I would have 25, because remember, two negatives make a positive. So when I square negative 5, it's really negative 5 times negative 5 to make it positive, plus 45. And 25 plus 45 then would get us to 70. And then I'm going to bring down my subtraction sign. So I have 69 minus 70, which would get us an answer of negative 1. Number 12, I need my equations back again. So in the v equation, we are going to substitute 11. And in the w equation, we are going to substitute 20. So I'm going to rewrite each equation. So negative 4 parenthesis negative 3 times 11 plus 11. And we have our plus sign. And we have a coefficient of 2. And we have 20 squared minus 9 times 20. So I'm going to go through and solve each part of the equation and then add those answers together. So first we get negative 4 times negative 33 plus 11, which is negative 4 times negative 22, which gets us 88. And in red we get 2 times 400 minus 9 times 20, which is 2 times 400 minus 180. 400 minus 180 gets us 220. And 2 times 220 is 440. So when I bring down my addition sign, we get 88 plus 440, which would be 528. The other thing that we're going to look at is variables. So remember that there's two variables that are important in this class. Independent variables, which is a variable that does not change based on other variables. So some examples of an independent variable might be time. So minutes, hours, days, years. We can't affect time that's happening. The dependent variable is the variable that changes based on others. Some examples of common dependent variables are money and distance. So we're going to write a dependency statement and identify the independent and dependent variable. So when we write a dependency statement, we have the dependent variable depends on the independent variable. So in number 13, we have calories you burn versus the time you work out. So we want to know which one is dependent, which one's independent. So the dependent one changes based on something else. So think about a situation where you're working out and the calories. So the time of working out, I can't change the clock to know how much time I'm working out. But however much I spend working out, my calories are going to change based on that, which means that the dependent variable is going to be the calories you burn, and the independent variable, which you have no control over, is the time you work out. Now, we say you don't have control over it because you can't change the time. 5 minutes is 5 minutes. 10 minutes is 10 minutes. An hour is an hour. You can't change that time frame. So our statement then is always dependent variable depends on independent. So we would say calories you burn depends on time you work out. So number 14, the number of songs you buy in iTunes and your iTunes bill. So remember to look for those clues that we talked about before. Do we see anything that involves time or money or distance? Well, in this case, we see our iTunes bill. So any iTunes bill is going to deal with money, so that has to be a dependent variable because it's going to change based on how many songs you buy. So our dependent variable is the iTunes bill. And our independent variable is the number of songs you buy. So we would say the iTunes bill depends on the number of songs you buy. Number 15, the score of the basketball game versus the point score. So in this case, think about a basketball game and people are shooting the ball into the net, and the more times it goes in the net, the more points that are scored, so the higher the score of the game goes. So we would say that the score of the game, of the basketball game, depends on the number of points scored. So when we write our dependency statement, we'd say the score of the basketball game depends on the number of points scored. Number 16, the time driving versus the distance traveled. So remember, again, we're seeing that time, that's something that we have no impact over. Time is going to continue to pass regardless of what we are doing. So anytime we see time, remember that that is an independent variable. So time driving is independent, which means distance traveled must be our dependent. So we're going to say the distance traveled depends on time driving. Number 17, the amount of pizza left versus the time the pizza is available. So again, we're looking for a keyword. We see time. That's something that we can't change at all. So our independent variable is time the pizza is available. And our dependent variable is the amount of pizza left. So in our statement, we would say the amount of pizza left depends on the time pizza is available. Number 18, it costs $14 for a large pizza. Each topping on the pizza costs $2.50. So write a dependency statement, identify the independent and dependent variables, and complete the table below. So the thing that we're talking about here is cost and our toppings. So think about when you order pizza, the cost of our pizza is going to change based on how much stuff you want on the pizza. So our dependent variable is going to be cost, and our independent variable has to be the toppings then. So in our statement, we would say the cost of pizza depends on the number of toppings. So when I look at my table, this also helps me. Remember, the input in your equation is always going to be your independent variable, while your dependent variable is going to be what we're getting out of the equation. So in this case, the cost of the pizza. So when I fill in my table, if I'm looking at toppings, now realistically, some of these toppings are a little bit high for our pizza, but we're just looking at the process in general right now. So on our pizza, if the pizza costs $14, I have to pay $14 for the pizza plus $2.50 per topping. So if we get 0 toppings, our pizza would cost $14. If we get 1 topping, we have to add $2.50 for the topping, so our pizza would cost $16.50. If we got 2 toppings, we'd have 14 plus 250 times 2, which would get us $19. If we got 10 toppings, 250 times 10 plus $14, our pizza would be $39.